Hi guys, today we're going to learn about rationalizing denominators and numerators. So in this section, I will rationalize numerators or the denominator by taking the conjugate, and then I will do some problems where I will simplify expressions. So let's get started. So to rationalize a denominator or a numerator of the form of a minus b square root of m, or a plus b square root of m, multiply the numerator and denominator by the conjugate. So that's how you rationalize this in the form of a minus b form. So an example would be 5. Let's say you wanted to rationalize this one, right? 5 over 2 square root of 3. This is not in a plus bm form, right? I just want to rationalize the denominator because I want to get rid of that. When I say rationalize the denominator, I want to get rid of that square root of 3. So I'm going to multiply square root of 3 both sides, and then that's how I get 5 square root of 3. So let's say you have, now let's actually do some problems where it's in a plus bm form, and I'll show you what I mean by conjugate. So let's say the first problem says rationalize the denominator of the expression, then simplify your answer. So I gotta rationalize, what am I gonna rationalize, the numerator or the denominator? I will rationalize the denominator, this thing, but the thing is, before I do that, I have to take the conjugate of that. So what do you think the conjugate of that would be? 5 minus square root of 3. The conjugate of that is always the opposite sign of this. So the opposite sign would be positive. So our conjugate would be 5 plus square root of 3, right? So my next step is I'm going to multiply top and bottom by the conjugate. So I'm going to multiply this by 5 plus square root of 3, and also the bottom as 5 plus square root of 3. So let's simplify the numerator. So we gotta FOIL this out too, and we're gonna multiply that 2 by over there. So 2 times 5 is 10, plus 2 times square root of 3 is 2 square root of 3. Now the bottom is, this one's a little bit easier, but I don't want to FOIL it out. There's a rule, it's called the, what is it called? It's this is the perfect square, right? The perfect square. So the perfect square, if you ever get confused about perfect squares, go to my video about FOILing factoring polynomials, and this will go over all the rules. So my a is what, 5? So it's a squared minus b squared. So 5 squared minus b squared. What is my b? So our a is 5, right? Well, my b is square root of 3. So b squared is just 3. Or how about this? Square root of 3 square. Let's fix the numerator. Can that be even more simplified? Let's see, we have 10 plus 2 square root of 3. We can't combine those two terms, but we can actually factor out something. What can we factor out? I would factor out a 2. If I factor out a 2, I'm going to get 2 times 5 plus 1 times square root of 3, or you could just leave it as square root of 3. There's an invisible 1 right here. Divided by, what is 5 squared? 25. What about minus, what is square root of 3 squared? It's just 3, right? Whenever you square a radical, the radical disappears. So 25 minus 3, let's simplify that. So the numerator is the same. divided by everything. 25 minus 3 is what, 11? Wait a minute. 25 minus 3 is not 11. It's 25 minus 3 is 22. Sorry. Yes, 22. But the thing is, the 2, what happens to the 2 and the 22? They both get divided by 2, so this becomes a 1, this becomes 11. So my final answer is 5 plus square root of 3 all over 11. So yeah, it was pretty simple. We just got to figure out, are we going to rationalize the numerator or denominator? And then we just take the conjugate of that and then multiply both sides and then simplify. Right? Not too hard. Let's see here. Now let's do this one. We have a 3 divided by square root of 5 plus square root of 6, right? I got it. So what am I going to do? Am I going to do rationalize the numerator or the denominator? Now the clue is it's always the one with the radicals in. So we're going to rationalize the numerator. So we're going to rationalize this. Now we got to find out the conjugate of that. So what is our conjugate? It's pretty much the same thing, but the different size, so the different sign. So this is not going to be positive, it's going to be negative. The next step is just multiply top and bottom by the conjugate. Square root of 5 minus square root of 6. Square root of 5 minus square root of 6. Okay, let's fix the numerator. So let's FOIL out that 3. So this is going to be 3 square root of 5 minus 3 times a negative 1, or negative is negative 3 square root of 6. Now remember, these can't be combined because they are both, this is square root of 5 and this is square root of 6, so we can't combine those two. So now let's fix the denominator. This one is also a perfect square, so what would be our a? Square root of 5, and my b is square root of 6. So this perfect square is a squared minus b squared, so I'll just do it right now. So what is a squared? Well, a is square root of 5, and square that, it would be just regular 5. So 5 minus, what is my b squared? So b is square root of 6, and then if you square that, that's just 6. Let's see. We can't fix the numerator. We can't simplify the numerator, right? But we can fix the denominator. So 5 minus 6 is negative 1. So this becomes, just put a negative 1 right here. Let me rewrite. So let me rewrite that. So that's going to be 3 square root of 5 minus 3 square root of 6 all over negative 1. Now this all over means we have to divide it by this by negative 1 and this by negative 1. So when you actually do all the work, you can leave it like this, or you can, let's see, FOIL it out. So this would be negative, remember everything, so negative 3 square root of 5, and then divide this by negative as well. So 2 negatives becomes a positive, so that's going to be positive 3 square root of 6. And that's it, because you can't combine all the like terms. Or what you could have done is factor out a negative, right? So this is going to be negative 3 square root of 5. this would be a positive square root of 3 square root of 6. And then the negative cancels. And then you're left with negative 3 plus 3. Yeah, same thing. Okay, so let's do, now I think we're going to do some rationalizing numerator. Oh, yeah, we're going to do some rationalizing numerators. So we were rationalizing denominators, let's rationalize numerators. So rationalize the numerator of the expression and simplify your answer. So I want to, basically when I see a radical, you want to get rid of it. So I'm not going to take the conjugate like last time because it wasn't in a plus mb form, right? It's just radical form. So how do I get rid of that radical 8? I'm going to multiply it by square root of 8, right? Top and bottom by square root of 8. So let's multiply across the numerator. So what happens when you times a radical times a radical? The radical disappears and you're just left with the number inside of the radical. And then 2, this becomes 2 square root of 8. Let's see here, we can actually, let's see here. We can fix the go a little bit more further. Let's simplify this square root of 8. So that would be 4 and a 2, right? So when you take, how this works is the prime number stays inside the radicand and the good one stays outside, but it's not 4, it's the square root of 4, which is 2. So it's like saying 8, 2 times square root of 2 times 2, because the square root of 4 is 2, and then square root of 2. So that becomes 8 over 4 square root of 2. This becomes more simplified. 8 divided by 4 is 2 over square root of 2. And then you could actually go one step further and rationalize everything by square root of 2, or you could just leave it like this. Okay, let's do this one. Let's say we have square root of 5 plus square root of 3 all over 3. So I want to rationalize the numerator, and you can tell because it's the one with the it's the one with the square root. So this one is in let's see, it's in this form, right? Let me show you. It's in a plus bm form, right? So you got to take the conjugate of that. So what would be the conjugate? It's always this, it's the same thing, but the only difference is the sign. So this is going to be a negative. Minus square root of 3. So we got to do it, multiply that top and bottom by this. Square root of 5 minus square root of 3 divided by square root of 5 minus square root of 3. Now let's, what do we know? These two, these are what's called the perfect squares. So my a is square root of 5, and I have to square that. And my b is square root of 3, and then you have to square that. FOIL this out, 3 times square root of 5 minus 3 square root of 3. So yeah, remember, this is a perfect, if you miss how to do perfect square, there's a video on factoring, foiling polynomials, and it just lists all the rules. Because I'm lazy and I don't want to FOIL it all out. So this is square root of 5 squared is what? 5 minus 3. Okay, can these be combined? 3 square root of 5 minus 3 square root of 3? Nope, because they're not the same thing. They're not the same radical. So that's just, it is what it is. 5 minus 3 is 1. And then you're left with 3 square root of 5 minus 3 square root of 3. Hold on. Before we go any further, let's look at the the denominator. We can't combine them, but we can actually take something out. We can take out a 3. So let me rewrite it. So it's going to be 1 over, we're going to factor out that 3. So this is going to be, I'm going to use bracket this time because it means everything. Square root of 5 minus, what is this going to be? It's going to be 1 because 3 times negative 1 is negative 3. So it's going to be negative square root of 3. Sorry, 5 minus 3 is not 1, it's 2. So this is your final answer. Okay, now let's actually simplify some terms together. So I want you to simplify each expression. So let's simplify this one. Let's see, that's 2 square root of 50 plus 12 square root of 8. Can these are not the same thing, right? Square root of 50 and square root of 8, so we can't combine them, but we can actually simplify these radicals, right? So let's do the 50. So what two numbers gives you 50? I'm going to use 25 and 2. Circle the prime number, which is 2. The prime number is the one that can only be timed by 1 and itself, right? So 1 and 2 is prime. This one, 2 is prime. And then the non-prime number, which is 25, is you put it outside the radicand, but it's not 25, it's actually the square root of 25. So it's going to be 2 times, what is the square root of 25? 5. Square root of the prime number, which is 2. So that was this one. So this simplifies as 10 square root of 2. Let's do this one. 4 and 2, 8. So let's do the 8. So two numbers multiplied by 8 gives you 4 and 2. So 2 is the prime number. The non-prime number goes outside the radicand, but it's not 4. It's square root of 4, which is 2. So it's going to be 12 times 2 square root of 2. So 12 times 2 is 24. So we're going to do plus 24 square root of 2. Now can we combine these two terms? We can, because they have the same radicand. You know, you could think of it as this radical 2. You could think of it as regular 10x, right? 24x. They can be combined. So how would I combine these? 24 plus 10 is 34. And then don't forget this. So, and then you're just left with the square root of 2. Okay, let's see here. Just a few more and then we're done for this section. So let's say we have 10 square root of 32 minus 6 square root of 18, right? Let's simplify. So these are not, radical 32 and radical 18 can't be combined because they're not the same, but we can simplify these. Two numbers multiply 32. I'm going to do 4 and 8. Let's see. The 8 can be simplified as 4 and 2. Circle the prime, which is 2. Now, do you see this 4s? It's not, it's going to be 10 times the good number, which is 4 and 4 is 16. But what is the square root of 16? 4. So whenever these repeat twice, you just write it as once. So it's just going to be 4 square root of 2. Now let's focus this part. Two numbers multiplied 18. We can do 9 and 2. The 2 is the prime. You can take the square root of 9, which is 3, so it's going to be minus 6 times square root of 9 is not 9, it's square root of 9, which is 3, square root of 2. So this is going to be minus 6 times 3 is 18, square root of 2. Now these can be combined because they both have the square root of 2 of radical. Wait, so what's 10 times 4, which is 40, right? 40 square root of 2 minus 18 square root of 2, that would be 22 square root of 2. Let's see here. Let's do this one. We have 3 square root x plus 1 plus 10 square root x plus 1. So what is this going to be? Let's see. This one looks a little... Yeah, this one's simpler because we can actually combine it. We don't have to... Do you see the square root of x plus 1, square root of x plus 1? Since they're the same, we can combine it. So we just got to combine this term and then this term. So what's 10 plus 3? 13. And then bring down the radical, which is x plus 1. That one was simple. What about this one? This is our last one. So we have 7 square root of 80 x, and the x is inside the radican, minus 2 square root of 125x. They can't be combined because they're different, but they can be simplified. So let's start with the 80. Two numbers gives you 80 would be 4 and 20. 20 reduces, simplify as 5 and 4. The prime number is 5, right? And then you're left with, I'm going to box 4 and the 4. So it's going to be 7 times. Remember, when you have a pair of the same number, you just have to write it once. So it's 4 square root and then 5, and then don't forget the x. Now let's do the 125. So 125, two numbers multiplied, 125 is 5 and 125. Oh, no, sorry, 5 and 25. 5 and 25, so square root of 25 is 5, so wait, so the 5 is the prime, I'm going to circle that one. And then the good one goes outside the radican, but it's not 25, it's the square root of 25, which is 5. So it's 2 times 5 square root 5 and then the x. So it's going to be minus 2 times 5 is 10 square root of 5x. Now we combine the like terms. Oh, what's 7 times 4? 28, right? So since these are the same radicans, our answer is going to be square root of 5x. And then it's 28 minus 10, which is 18. And that's your final answer. So that wraps it up for this section.